using histograms to answer statistical questions. So we're going to draw a histogram and use them to answer some questions. Or I can draw a histogram from a table of data, and I can use a histogram to describe the distribution of data and determine a typical value for the data. So make sure you have today's date, your ICANs, and you're ready to move on. All right, which of these does not belong? So we got 4 questions about the population of Alaska. Which one doesn't make sense? We got, in general, at what age do Alaska residents retire? At what age can Alaskans vote? What is the age difference between the youngest and the oldest Alaska residents with a full-time job? And which age group is the largest part of the population? 18 years old or younger, 19 to 25, 25 to 34, 35 to 44, 45 to 54, 55 to 64, or 65 or older. So when I'm looking at these, I really think that the one that doesn't work with the other ones, oops, sorry about that. The one that doesn't work with the other ones, I think you make an argument for a lot of these, right? Number 4, you'd have to get a lot of data to find. Number 3, you'd have to sort through some data as well. Number 2 is just a one answer. It's whatever legally you can be to vote. You probably would have to dig through some data for what age do Alaska residents retire. So you'd have to go through and find out retirement ages of at least a sample size of people in the state, and then decide what was the most common or the closest to the middle of those ages to try and figure out at what age Alaska residents retire. I think the other two, you're still pulling data either way. Here you got to find, out like how old people are with a full-time job, and then once you find all that data, then take and find the difference between whatever ends up being the youngest and whatever ends up being the oldest. That could almost Google that answer. No, you'd probably still have to get some different information from different websites or from different sources and compile it together. Really, for all of these, except for number 2. Number 2 is the only one that I really can't see a reason to use for anything else. I mean, this is going to be more categorical than the other ones. This one here is going to be, talking about the spread between the oldest and the youngest. Here, this one's not statistical because it's just one single one. This one, this is going to be looking at the center of what you get as opposed to looking at the spread that you would get in this answer here. So I think you can make the argument for any of those not being in, just kind of depending on what things you were looking for. Okay. So we're going to talk about histograms today. So let's get this jotted down real quick. A histogram is a way to represent data on a number line. This is key part. Data values are grouped by ranges, and the height of the bar shows how many data values are in that group. So group is kind of the big thing here. So here's an example of one. We've got widths of some different leaves. Those that were between 1 and 5 centimeters, we found some there. Between 6 and 10 centimeters, 16 and 20 centimeters. So each of these has a range going across, and then the number of leaves that we find in there are compiled together. Now, we can't tell, like here in 11 to 15, we know that most of them were between 11 and 15 centimeters, but I can't tell you how many of them were 12 centimeters, can I? It does give me some general data, and that's the thing with histograms. They tend to be just data. So you can see histograms are kind of like dot plots kind of compressed together. So instead of making this massively long dot plot, you could instead make a histogram that would give you more general information to go through and do. Okay? All right, let's talk about some earthworms. There's some great information. You can pause there if you want to look at it, but we got to move on. An earthworm farmer set up several containers of a certain species of earthworms so he could learn about their lengths. The lengths provide information about their ages. Farmer measured the lengths of 25 earthworms in one container. He measured them in millimeters. Okay, so here's their lengths. Conveniently, he organized it already for us in detail. So what would go here, the number 0 millimeters to less than 20 millimeters. Yeah, it's going to be these four here, right? 20 millimeters to less than 40, so that means 39 is the max. 4, 5, 6, 7, 8, 9, 10, 11, 12. I would jot these down. They will help us in a little bit. 40 to less than 60. 1, 2, 3, 4, 5, 6. 60 to less than 80. Yeah, it looks like we just got 2 there. And then 1 that is more than 80 and less than 100. Okay. Clean that up a bit. Okay. So, actually, what we're going to do is we're going to take that information and I'm going to expand this just a little bit so it covers the other, and that's okay. Oops. There we go. Okay. So what we're going to do is we're going to have a histogram here for this. Now, what they've done with this histogram is this is a little bit different than what we saw back in our definition. So in our definition, we had the ranges saying through. You can see sometimes with them where you have the range goes to a particular number. So then, 0 to 10 would go here. Then you had 10 to 20 would go here. Using what they shared with us, we're going to kind of do some wider chunks on what they're showing here. So this is not too hard for you to draw out. You can even go through and use at the bottom of your notebook paper and draw your y-axis and your x-axis and just use the blue lines because we're not going to use too many. In fact, we're only going to use maximum of 12. So you can put that at the bottom of your notebook. Okay. So 0 to 20, so that's going to be in here, and we had up to 4. So you'll be able to shade that in a lot better than I will. Let me fix that. It's a little wide there. Okay, and then from 20 to less than 40, we go up to 12. Yes, I could do. Actually, let me do that. All right, so I'm just going to do this so you're not watching me take forever to draw them out. All right, so that one went up to 12. Next one goes up to 6. And they kind of overlap. That's what they're supposed to do. Which is a little difficult with this, but I'm sure you're drawing it much more efficiently than I am able to draw it out on here. Probably already done with drawing all these as I'm trying to mess with this to make it so it looks cleaner and easier to read off of what I've got. Okay. All right. Enough complaining, Mr. Pellin. Just get it finished. I am getting it finished. Why are you not happy with this? I am. You know, you're kind of talking to yourself, right? Yes, but students will listen and be confused. Anyway. All right. And the final one. This goes down. Yeah, this one goes down, way down. All right. So with all that, we can see some things, right? What's a typical length of these? Yeah, it's somewhere between 20 and less than 40, right? The most of them fall in that range. And we can tell that because that's where the largest part of them are. Very few get to, once you start getting past, 60 millimeters, they really start getting fewer and fewer that length. So this is their length, because we have to label in millimeters. And then this is just the count for each one. Okay. So in a histogram, can we see clusters of values in the distribution? Oh yeah, we saw a bunch of clusters in that, right? We saw, numbers that were similar or close to each other, all clustered together. Could we see the largest and the smallest value? Yeah, and we could we didn't know the exact largest and the exact smallest based on that. We know that they were in that range. And could we tell the overall spread? Yeah, the spread we were able to kind of figure out more, right? We're able to see that it was more closer to that 20 to 40 range. And then how do we figure out the center of that distribution? Yeah, it was just like we talked about, how between 20 and 40 millimeters was the longest length, or it was the most typical length, because that had the most at that. All right, let's talk a little bit of basketball. All right, so we have professional basketball players tend to be taller than professional baseball players. I guess we're talking about both. So here's two histograms of 50 male professional baseball players and 50 male professional basketball players. Which one of these is basketball and which one's baseball? Yeah, this is probably the basketball one, right? Why? Well, look, we've got one here that's between 70 and 72 inches. And then everything else really about 76 inches. We're starting to get, most of these are more than 6 feet. So as you get further and further, you're starting to get into very tall people. Whereas here, most of them are somewhere kind of centered in this around the 6 foot range, or 72 inches. Okay. So what about the distribution of the basketball players? Yeah, most of them tend to be somewhere between 76 and 82 inches tall. But there can be players that, we do have some outliers going up to 90 inches and as low as 70 inches. So the spread is pretty wide, but we have the center of most of it is somewhere in here. Whereas the center in baseball is mostly here between 72 and 74 inches. And that our spread isn't nearly as wide as it is here. Most of it, if you would look at just this chunk, it's pretty similar to this, but there are those parts that outlie from that. All right, so what are some things that we have to think about before we make a histogram? Yeah, we have to identify the ranges that we're using, right? We're going to be using numbers specifically with it. We're not going to be using other category data. Does the width of the bar have to represent 5 units every time? Can be 1 unit, can be 5 units, can be 2 units, however. And what is the horizontal axis usually? That x-axis across the bottom. Yeah, that's usually our ranges, isn't it? I mean, if you think back on this previous one and on any of the others, our ranges were down here, right? But when we talked about our vertical, our y-axis, that was the number of people that were involved or the numbers that went with those ranges. And how tall do we make each bar? Well, that's just the total that go in that particular data range, right? All right. So how would we, taking a look at this, describe the typical weight for the dogs in this group? Yeah, their typical weight is somewhere between 20 and 25 kilograms, right? What about the spread? Yeah, it spreads somewhere between 10 and 35 kilograms. So there's kind of a wide spread there, okay? All right, I think we've hit everything. And, oh, yep, a little long, but a lot to talk about there. So, hey, thanks for hanging in.